Start.
Good morning, students. Welcome to webinar class. This is Shankaraiah Kallapalli, JLN Physics, Tsrjc Thatipally, District Jagitya. Now, I want to explain of previous class. A little bit of, so the first heading in the chapter is a magnetic effect of current. Has-sted experiment. Go to once again explanation. When a current flow through a conductor, a magnetic field produced around the conductor. The direction of a magnetic field depends on current flow through the conductor. Imagine that current carrying conductor is perpendicular to the plane of paper. When a current out from the plane of paper, I show in figure dot within the circle. Magnetic compass needle, north pole deflected towards left hand side. When the current into the plane of paper, I show in figure cross within the circle. Here, south pole of a magnetic compass needle deflected towards left hand side. This is called as a Ampere's swimming rule. Ampere's swimming rule. First one is over. Next, Ampere's law. Next one, Ampere's law. The line integral of dot product of B comma dl is equal to mu naught times of total current in a conductor. According to statement, integration B dot dl is equal to mu naught into I. Here B dot dl, according to dot product definition, B dl cos theta, where theta is the angle between B comma dl. Next here, mention the direction of your magnetic field according to right hand thumb rule. Right hand thumb rule. If a current carrying conductor imagined to be held in a right hand, like this here, held in a right hand. Your thumb is stretched. Thumb is stretched along the conductor. Thumb represents the direction of flow of current. Remaining fingers represent direction of magnetic induction. Direction of magnetic induction. Ampere's law is over. Next, first application in this Ampere's law, magnetic induction due to current carrying conductor. Consider a conductor carrying current I, magnetic field produced around the conductor with radius r. The circumference of the magnetic field can be divided into small elements, and length of each element is dl. Draw the tangent line at element. The tangent line indicates direction of magnetic induction. Here, dl, B are parallel to each other. According to Ampere's law, integration B dl cos theta is equal to mu naught into I. Here theta equal to 0 degrees. Cos 0 value 1. Here the right here integration B ds is equal to mu naught into I. Mu naught into I. Here B is a magnetic induction. Its value remains constant. Magnitude remains constant. Direction changes. Here B integration ds or dl is equal to mu naught into I. But integration ds is equal to S. But S is a length of the circumference of coil. Here circumference coil is what? Here 2 pi r or 2 pi a. Here radius of the coil is taken r, then right here 2 pi r. Radius of the coil will be taken as a, then right here 2 pi a. After here b, that's equal b into 2 pi r, that's equal to mu naught into I. B, that's equal to mu naught I divided by 2 pi r. This is the expression for magnetic induction due to current carrying conductor. Very, very important IP purpose, Ampere's law and magnetic induction due to current carrying conductor. Next, we go to Biot-Savart law area. Biot-Savart law. Consider very small element of length dl of conductor carrying current I. The magnetic induction at point P due to element dl and resistance R from the element is dB. dB is directly proportional to current flow through the element. dB is directly proportional to length of the element. dB is directly proportional to sine angle between dl, R. And inversely proportional to square distance, inversely proportional to square distance between element to point P. Simply here dB is proportional to ideal sine theta divided by r square. Remove the proportional symbol. Here, remove the proportional symbol, sir. We get the constant. Write the constants are here. That constant value taken as mu naught by 4 pi. Here, dB is equal to mu naught by 4 pi ideal sine theta divided by r square. Where mu naught is permeability in vacuum. It is the property of a medium which produces the magnitude of force between two poles of a bar magnet. Okay, sir. This is write the vector forms are here. How to write the vector forms are here? dB is equal to mu naught by 4 pi ideal sine theta divided by r square. Multiply and divide with r. Then right here multiply and divide with r. Here next step what to do, sir? Here dB that's equal to mu naught by 4 pi I dl r sine theta divided by r square into r. Nothing but r cube. Here mu naught is a constant. I is a electric current is a scalar quantity. Because it does not obey addition of two vectors. Here electric current having magnitude and direction, but it does not obey addition of two vectors. It is a scalar quantity. Then right here we are mu naught I divided by 4 pi r square r cube r dl sine theta. Here dl r sine theta. Like here this is the according to vector prediction. Here dl r sine theta like a b sine theta, a bar cross b bar, that's equal to ab sine theta. Here then right here dl bar cross r bar. Write a vector form. dB bar is equal to mu naught by 4 pi into I. dl bar cross r bar divided by r cube. This is a vector form. But here, this current carrying curved wire having n number of elements. N number of elements. We calculate the total magnetic induction at point P using integration. Integration dB is equal to integration mu naught I divided by 4 pi dl bar cross r bar divided by r cube. This is a vector form. Biot-Savart law is over. Next we go to magnetic induction at the center of current carrying circular loop. Go to this one, Sharia. This is a previous class I am explained, but once again review. Got it? Okay. Consider a circular coil of radius A carrying current I. A magnetic field produced at the center of the coil. The direction of magnetic field perpendicular to the plane of the coil. Perpendicular to the plane of coil. The coil can be divided into small elements. Coil can be divided into small elements. The length of the each element is dl or ds. dl or ds. Okay, dl, then right side here dl. Got my concept here. Here, radius and element length of the element dl are perpendicular to each other. Perpendicular to each other. According to Biot-Savart law, dB that's equal to what do you write, sir? Here dB that's equal to integration dB that's equal to integration mu naught by 4 pi IDL sin theta divided by r square. But theta equal to 90 degrees. Theta equal to what, sir? Here 90 degrees. So why to 90 degrees, sir? Here theta be the angle between angle between dl comma r. Here dl comma r are perpendicular to each other. Here sin 90 value is when? Sin 90 value is when. Then write integration dB means b is equal to integration mu naught by 4 pi I dl divided by r square. Mu naught is a constant, 4 pi is a constant, I is a constant, here r square is a constant. Common it. B is equal to mu naught I divided by 4 pi a square or r square. Integration dl nothing but here L. Integration dl, mathematical formula. Integration dl is equal to L. L is a length of the circumference of coil. Your circumference coil is 2 pi r. 2 pi r. 1 r get cancelled, pi get cancelled, 2 2 is 4. B is equal to mu naught I divided by 2r. Mu naught I divided by 2r. This is a magnetic induction at center of current carrying circular loop or coil. But the coil having n number of turns. N number of turn. First turn, second turn. That coil having how many number of turns? N number of turns. Then right here, magnetic induction B that's equal to mu naught I capital N or small n. Which one we consider? Then write that one, sir, here. Mu naught I N divided by 2R. This is the previous class. Next today, now we are discussing about second application of Biot-Savart law. Go to second application. Second application is a magnetic induction at a point on axial line of current carrying coil. Go to that one, sorry, today. Okay. Just to review, Einstein experiment is over. Next, Ampere's law once again is over. Next, magnetic induction due to current carrying conductor, Biot-Savart law. Next here, this is the vector form already I'm explained. This R cap is a, like this here, this is the, I'm right here, this is the R cap. R cap is a unit vector, sorry. R cap is a unit vector. What is the unit vector? A vector whose magnitude is equal to 1 unit is called as a unit vector. R cap is equal to R bar divided by R. DL bar cross R bar divided by R. R square into R, like this here. This is the R cube. Got my concept? Its volume, unit volume 4 × 10 power minus 7. Here, Tesla meter for ampere, Weber for ampere meter, or Newton for ampere square. Already previous class explained, so here. Got it here. This is a magnetic induction center of current carrying. Circular loop also explained, so here. This is the today concept, sorry. This is what's here today concept. Got it? My concept here. Magnetic induction at a point on axial line of current carrying coil. Go to that one, sorry here. Listen careful, my concept here. Here, like this here, this is the my concept, sorry here. This is the coil, sorry here. This is the coil. This is the coil, sorry here. This is the coil, like this here. This is the coil. Having here n number of turns, sorry here. This is the coil. Having n number of turns. This is the element, sorry, like this. This is the element. This is the element. This is the line, sorry, like this here. This is the line. One line. This is the line. Axial line, sorry. A line passing through the center of the coil and perpendicular to its plane. This is the axial line. This is the axial line. Got it, my concept here? This is the experiment, like this here. Got it, my concept here. Okay. Next, go to concept, sorry. Okay. Consider a circular coil of radius A, like this here. This is a circular coil. This is the circular coil, so like this here. This is a circular coil of radius A. This is the radius is A. And carrying current I, like this here. Carrying current is I. A magnetic field produced at the center of the coil. Here, magnetic field produced. But we shall calculate the magnetic induction at a point, an axial line of axial line at a point P, an axial line of current carrying circular loop, and at a distance OP is equal to X. OP equal to X. Here, current carrying coil can be divided into small elements. The length of each element is dl. The length of each element is dl. The magnetic induction at point P due to element dl and the distance r is dB. Is dB. Is dB, sorry. According to here Biot-Savart law, what do you read, sir, here? According to Biot-Savart law, dB that's equal to mu0 by 4 pi ideal sine theta divided by r square. R square. But here, listen careful, my concept. This is a length of the element dl. This here r perpendicular to each other. This element dl and r are perpendicular to each other. Like this is the element. This is the like a element. My finger like a. This is the element. This is the r. Sorry, this is the r. This is the r. This element and element and r is normal to each other. Normal means perpendicular. The angle between the element and r is 90 degrees. 90 degrees. Like this here, put it here 90 degrees. Here put it 90 degrees. Here the right side here like this here. dB that's equal to mu0 ideal sine theta divided by 4 pi r square. Theta equal to 90. Sine 90 value is 1. Mu0 by 4 pi ideal divided by r square. Ideal divided by r square. This is a magnetic induction at point P, an axial line of current carrying circular coil. Once again, go to figure, sir. Listen carefully. Like this here, dB direction is this is a dB direction. This dB direction is perpendicular to the plane of dl comma r. dl comma r. dB is a vector quantity. dB is a vector quantity. Its direction always perpendicular to the plane of dl comma r. dl comma r. Got it, my concept? Why, sir, here? dB is a vector quantity according to vector product. According to vector product, the cross product of two vectors gives vector. The cross product of two vector gives vector. Sir, which one vector, sir? Here, dl bar is a vector. Length of the element is a vector. Sir, why to it is a vector quantity? Draw the tangent line at element. Draw the tangent line at element. The tangent line indicate direction of element. This is the R is a distance from element to point P. Here direction where to where? Element to point P. This R comma DL are perpendicular to each other. Next here, DB also perpendicular to the plane of DL comma R according to product of two vectors. According to product of two vectors, which vectors are here? Vector product. The product of two vector gives vector. Like this one vector is what's here like this. One vector is a DL bar, another vector is a R bar. This is a DB bar. Direction is perpendicular to the plane of R bar and DL bar. DL bar. Take another opposite element. Like this here, another opposite element of length here, length of the element is dl. Length of the element is dl. Magnetic induction at point P due to element dl and distance r is dB. Like this here, this dB direction, this downward direction here, dB. Here dB that's equal to similar concept. dB that's equal to mu naught by 4 pi ideal sine theta divided by r square. Ideal sine theta by r square, similar concept. But here dl comma r are perpendicular to each other. Theta equal to, once again then right here, 90. Here sine 90 value is when? Sine 90 value is when? What do you write here? dB that's equal to mu naught ideal divided by r square. This dB direction also perpendicular to the plane of r bar and dl bar. Like this here, this is a dB direction. Sorry, this is a dB direction. Got it my concept here? dB direction is always perpendicular to the plane of dl bar comma r bar. This dB direction also perpendicular to the plane of here dl bar comma r bar. This here, draw the vertical axis. Sorry, this vertical axis. Sorry, vertical axis. This dB making an angle pi with vertical axis. This vertical axis. Here, this dB also making an angle here pi with the vertical axis. This vertical axis. Sorry. The dB can be resolved into two perpendicular component. Which vector making some angle, that vector can be resolved into two perpendicular component. The horizontal component like this here, this is a horizontal component is dB cos pi. Here vertical component is dB sin pi. dB sin pi is parallel to the axial line. dB sin pi acting along axial line. In this here, these two components are satisfy addition of two vectors. Addition of 2 vector. Like this here, this horizontal component terminal point, vertical component initial point coincide. Then these two vectors are in same order. The sum of two vectors in same order represented by third vector. Third vector is known as addition of two vector. Addition of two vector is satisfied in this case. Got it my concept here? Here addition of two vector is satisfied. Here also addition of two vector is satisfied. Got it my concept here? Here addition of two vector is satisfied. But here 1 dB cos theta is acting vertically upward direction. Another dB cos phi, dB cos phi acting vertically upward. Another dB cos phi acting vertically downward. dB cos phi, dB cos phi. Magnitude equal but directionally opposite and cancel to each other. So why to cancel? Your question. Got it my concept? This is a dB cos theta is a like a p bar vector like a. This a dB cos theta is a q bar vector like a. Got it here? According to parallelogram law of vector. Parallelogram law of vector. What is the resultant vector form? Under root of p square plus q square plus 2pq cos theta. Here theta is the angle. Here angle almost are here. This is the angle between dB cos phi and dB cos phi is 180 degrees like this. This is 180 degrees. Cos 180 value is 1 minus 1. Then right here under root of p square plus q square plus 2pq. Cos 180 value minus 1. Then write minus 1. Under root of p square plus q square minus 2pq. This is like a minus b whole square. Here under root of p minus q whole square. Square root cancel. R that's equal to p minus q. R that's equal to p minus q. P is like a dB cos phi. Q is like a dB cos phi. dB cos phi minus dB cos phi. Nothing but 0. Got it here? Resultant magnetic induction along vertical axis. Along vertical axis will be 0. Like this here, this is a dB sin phi and another dB sin phi acting along axial line. Acting along axial line. Parallel to each other. dB cos phi and dB sin phi and dB sin phi is parallel to each other. Same parallel means here theta is equal to 0 degrees. According to parallelogram law of vector, here magnitude of resultant vector are equal to under root of p square plus q square plus 2pq cos in place of theta 0 degrees. Cos 0 degrees value 1 under root of p square plus q square plus 2pq. This is like a plus b whole square. Here p plus q whole square. Square root cancel. Square root cancel. R equal to p plus q. Here p is like a dB sin pi. Q is like a dB sin pi. Here dB sin pi plus dB sin pi. Which one equal to resultant magnetic induction at point P is dB. dB is equal to what do you read, sir, here? 2 dB sin theta. But this coil having n number of elements. Here we calculate the total magnetic induction at point P due to all elements of the coil using integration. Integration dB is equal to integration dB sin pi. Integration dB sin pi is there. Got it, my concept? Here B is equal to integration dB sine pi. This total explanation is over. Got it, my concept here? Here theta with angle DL and R is 90 degrees. Already you know, sir. The sine 90 value is 1. dB equal to mu naught IDL divided by 4 pi R square. Next here, this pi is a angle between vertical axis and direction of magnetic induction. Like this here, dB is resolved into two components, dB cos phi and dB sin phi. Here, due to diametrically opposite current element, also same here, cos phi are here, dB cos phi are here. Here, like this here, components are always opposite to each other, and hence they cancel out each other. I'm explaining this one. Next here, sin pi components due to all elements DL get added up. Added up means what, sir? Here dB is equal to 2 dB sin theta. Sorry, sin pi. dB is equal to 2 dB sin pi. Angle, sir. Got it, my concept here. 2 dB. But here the coil having here n number of elements. We calculate the total magnetic induction at point P, an axial line of current carrying all elements using integration. Here integration dB, that's equal to integration dB sin pi. Integration dB nothing but B. Okay, B is equal to integration dB sin pi. But dB equal to what is the formula? Is there? dB equal to mu naught by 4 pi ideal sin theta divided by R square. Put it here. Mu naught ideal divided by 4 pi R square into sin pi. Here mu naught is a constant. I is a constant. Here sin pi is a constant. 4 pi is a constant. R square is a constant. Common in the terms. Here mu naught, then right here mu naught I sin pi divided by 4 pi R square integration dl. Integration dl. Integration dl nothing but L. L is a length of the circumference of coil. Length of the circumference coil is what, sir? Here 2 pi a. 2 pi a is a radius. But here sin pi, here mathematical formula here, sin pi it's equal to opposite side by hypotenuse. Like this here, go to one second here, go to diagram, sorry here. Okay, listen, concept here, this is angle. Here angle opposite side is A, hypotenuse is R, sin pi that's equal to here A by R. But here determine the R value here. This is a right angle triangle. This what's here? Right angle triangle, like this. Right angle triangle according to Pythagoras theorem. Here hypotenuse square R square is equal to base square. This is the x square plus height square a square. R square equal to x square plus a square, or a square plus x square. R equal to a square plus x square whole power 1 by 2. Whole power 1 by 2. Okay, next then right here, listen my concept. Like this here 2 pi a, like this here sin pi. Sin pi that's equal to, your opposite side is a divided by hypotenuse is a small r. But small r equal to what? A square plus x square whole power 1 by 2 according to Pythagoras theorem. Okay, a square plus x square whole power 1 by 2. I am right. But here, listen carefully, r square. Already I'm explained here. Like this, r square is equal to what? Like this, this is the, listen carefully. Here r square is a hypotenuse square. is equal to what, sir? Here a square plus x square, according to the diagram. According to diagram, here a square plus x square into a square plus x square whole power 1 by 2. Got it? Next here, this is the bases are equal. Then add the powers. Add the powers. Here a into a square. Okay, a square. Here pi get cancelled. 2 2s are 4. Then write here 2. Here a square plus x square whole power 3 by 2. This power is 1. This power is 1 by 2. Bases are equal. Then add the powers. Add the power. This power is 1. This power is 1 by 2. 1 plus 1 by 2. Nothing but 3 by 2. Here B is equal to mu naught I a square divided by 2 of a square plus x square whole power 3 by 2. 3 by 2. I am right here like this here. This is the mu naught I a sin pi r constant integration dl is equal to 2 pi a. 2 pi a. R and sin pi r replaced with measurable and constant values. Like this here, constant values I am right here. Constant values like this here. A by a square plus x square whole power 1 by 2. Here this is sin pi values are. Next here dl value integration dl nothing but here L value is here 2 pi a. 2 pi a. Next here r square value is a square plus x square. Got it, my concept? Okay. Here b is equal to mu naught I a square divided by 2 of a square plus x square whole power 3 by 2. This is a very, very important expression useful in 8th chapter, magnetism and matter. The same concept is there. This is useful. Here expression, what is the expression once again? B equal to mu naught I a square divided by 2 of a square plus x square whole power 3 by 2. Magnetic induction at a point on axial line of current carrying circular coil is B. B equal to mu naught I a square divided by 2 of a square plus x square whole power 3 by 2. This is the second application of Biot-Savart law is over. Next we go to this continue concept. Sorry, here A is the radius of the coil. Radius of the coil. Here some books, this is the A will be taken as considered as a R also. Okay, same similar concepts are put it in plus of A, then put it here R. What do you write, sir? Here, put it here R, mu naught I, R square divided by capital R, then right here. Small R already used. Okay, capital R, then right here. Mu naught I, capital R square divided by 2 of capital R square plus x square whole power 3 by 2. This is the magnetic induction expression. Next, you go to continue concept, another application, magnetic dipole moment of current law. Like this here, listen carefully. This is a current law. Here I am taken radius of the coil is here R. This radius of the coil is R. In previous one here, radius of the coil is A. Got it, my concept here. Okay, this is the consider a circular coil of radius R carrying current I. Magnetic field produced at center of the coil. Already know, sorry, the magnetic induction. The magnetic induction at point P, an axial line of current carrying coil and a distance OP is equal to X is B. X is B. Here magnetic induction is B. B equal to what you read here, already derived expression. Here B is equal to mu naught I N R square divided by 2 of X square plus R square whole power 3 by 2. Sir, what is the N, sir? N is the number of turns of the coil. Coil having N number of turns. Here this coil will be taken here. This coil having here N number of turns. N. But here only this coil having here 1 turn. This coil having here 1 turn. Here N value put it here 1. Then write here mu naught I r square divided by 2 of x square plus r square whole power 3 by 2. If x is greater than r, this compared to radius of the coil, this distance is large. This x value is removed from the expression like this here, mu naught I n r square divided by 2 x square whole power 3 by 2. Which one removed? Sorry, here r value is removed. Why is removed? X is greater than r. Like this, radius of the coil is very small compared to distance x. This x value is negligible. Like they remove that one share here compared to r sir. Then write here 2 of x square whole power 3 by 2, 2 get cancelled, here x power 3. Here mu naught I n r squared by 2x cube. Like this here, multiply and divide with here 2 pi, sorry. Multiply and divide with 2 pi. Here multiply and divide with 2 pi. Then write here 2 pi r square. Here 2 into 2 pi nothing but 4 pi x cube. Mu naught I n 2 pi r square divided by 4 pi into x square. But pi r square is the area of the coil. Pi r square is the area of the coil. Like this here, pi r square is equal to A. Here mu naught I n into 2A divided by 4 pi x cube. Then write here magnetic induction B is equal to mu naught by 4 pi 2 I n A divided by x cube r n equal to 1. Here B is equal to mu naught by 4 pi 2 I A divided by x cube. Similar concepts are here. Similar concept is here. Here take this coil will be taken here. Coil will be taken. Here coil magnetic induction expression at a point on axial lines are here. B is equal to mu naught by 4 pi 2 I n A divided by x cube. But here magnet will be considered, sorry, here magnet. This is the magnet, sir. Bohr magnet. This Bohr magnet having how many poles are here? 2 poles. This is North pole. This is the South pole. Like this here, magnetic induction at a point, an axial line of Bohr magnet, and distance x is and distance x. Where to x? Where x are here? Here point O to yes, midpoint of the Bohr magnet to point P. Distance is x. Here magnetic induction is B. Here B constant expression is B is equal to mu naught by 4 pi 2 m by x cube. This derivation is there in old book. This is removed from the syllabus. According to new syllabus, B is equal to mu naught by 4 pi 2 m by x cube. This comparing equation 1 and 2, sorry, compare, sorry, 2 mu naught by 4 pi mu naught by 4 pi INA. Here m is there, x cube in place of m. In place of m in place of m, which one is there, sir? Here INA. Here magnetic moment or magnetic dipole moment. M is equal to INA or NIA. N is a number of turns. Remove here, only taken here. N equal to one turn. Then write here m is equal to what do you write here? IA. I is a current. A is a area of the coil. Like this here, this magnetic moment is a vector quantity. I don't know, sir, here what is the magnetic moment? What is the magnetic moment? The product of length of magnet and its pole strength. The product of length of magnet in its pole strength is called as a magnetic moment. Magnetic moment is a vector quantity. Its direction from south pole to north pole. It is a vector quantity. It is a vector quantity. Which one is a vector quantity? Which one is a vector quantity? Magnetic moment is a vector quantity. According to this formula, magnetic moment units A is electric current measured in ampere. Here A is a area of the coil measured in meters square in a SI system. Like this here, magnetic moment. SI system unit is ampere meter square. Magnetic moment, SI system units is what, sir? Ampere meter square. Like this here, according to this expression, write the units of magnetic moment, NIA. Sir, how to this here? Coil act as a dipole. Like this here, when current carrying coil in clockwise direction, like this here, clockwise direction, like this here, clockwise direction, then in front of the coil act as a south pole. Very important points are here. This one, what are my concepts are here? When current flow through the coil in an anti-clockwise direction, that in front of the coil, this coil act as a south pole, like this here. In front of the coil act as a south pole. This is south pole. Next, when a current flow through the coil in anti-clockwise direction, like this here, anti-clockwise direction, then in front of the coil act as a north pole, like this here. This is upward arrow symbol, here downward arrow symbol, like this here. This is the north pole. This is the north pole. Got it my concept here? This current carrying coil act as a north and south pole. It has a dipole moment. It has a dipole moment. Here dipole moment expression is m dot equal to Ia. Go to continue another application for magnetic moment. Magnetic moment. Magnetic dipole moment of revolving electron in circular orbit. This is a circular orbit, sorry. Consider an electron. This is the electron, sorry. Consider an electron E revolve. This is a revolve in circular orbit of radius R. This is a radius is R. Radius is R. This is a revolve. Which one revolve? Electron revolve.
Shankaraiah, sir.
Sir.
Conclude, sir. Conclude, sir.
Continue, sir.
Conclude, sir.
Okay, sir. Okay, sir. Okay. I will explain next class this one, Sharia. Okay, this one is ended today. Next, I will go to explain magnetic dipole moment of a revolving electron in a circular orbit. Next class, I will explain. Okay, listen careful my concept.